Hello everyone, welcome back. Today we're gonna continue our Linux fundamental file system basics. Today we are gonna learn about /home directory, /var directory, /boot directory and /temp directory. Let's start with our /home directory. So /home is a directory that stores personal data of a normal user. It contains picture, videos, file, everything of a user. Okay, so example of a /home directory is what we're going to do is we're going to go to our terminal and simply come to our and simply do /home. So what you're going to do is you're going to do /home. You'll see home is our directory. So what you're going to do is we're going to list home, what is inside our directory. So mine is this is your this you'll see a username and the file of your computer. This is basically my username. So let's see what /home is used for. So it is used to keep our data, our personal data, separate from the system file. It makes Linux multi-user friendly, allows system upgrade without deleting them. So system file that we discussed earlier, which is /bin, /etc/usr. So these are the system file used by our system, but /home is our user file that we as a user use them to store our file. So basically it is that. So what's inside our /home, our username? So basically it is basically the download, document, music, videos that you see. So for example, let's go to again to our terminal and we do /home and my username, right? So what I'll do, I'll see bunch of the folders which are my personal file. These are my personal file that I keep in my machine. So these are listed in our /home. So there are hidden files also in our in our /home. In order to access our hidden files, what we're going to do is simply go do ls-a. So -a is list all, means list all the files in our /home username, and you'll see bunch of our file. You'll see some files starting from dot. So these are basically our hidden files. Okay, so this starts with dot. So basically you'll see something like .bash, .local, .pki. So these are the hidden files. So .bash c is used for shell setting. Config .config is used for application config. So why are they hidden? So they store why are they hidden? Because they store user configuration, prevent accidental deletion, mostly not meant for edited. Shell setting uses them, so that's why they are hidden. One example is that setting is unchanged even when your system is booted. So these are the example of hidden files. So permission and security of our /home. So each user can access their own directory, other user cannot access your file. Root is separate from /. Please note that /root and /home is very different. /root is a root user, while /home is for normal user. Okay, so /home is not required for system boot. If /home is deleted, system will run, but mind you, user might lose the data. So it is often placed on a separate partition for safety. Now let's move to our second directory, which is /var, var. So var stands for variable data. So it stores file that changes frequently while the system is running. So unlike /bin, /sbin or /usr, /var is not static, it is dynamic. So why var exists? So to keep growing and changing file separate, prevent system directories from filling up, helping in logging, caching and spooling. So we are going to discuss some of the subdirectories used in /var. They are log, cache and spool. So what is /var/log? So log basically stores, so it means it stores system log. So example of /log, which is, come to this, let's list what are this. You'll see log. So it stores a system log. Example of this is Okay, example of this is some of the important only we'll be discussing. You will see authentication log, right? You will see system log, so you'll see kernel log. So what are those? So authentication log is, it tracks login attempt, SSH, sudo's UI, password changes. So hacker looks for the failed password to see if someone is brute forcing the machine, so it is used for that. So slash log, this system log, it tracks general system messages that caches all log. If system crashes, right, a weird script runs, the error message ends up here. Another one is kernel log. So this one is kernel log. So there it is. This kernel log, it tracks kernel message from hardware driver firewall. So hacker checks if a buffer overflow exploits, crash the system memory. Is basically is for that. So there are multiple, but these are the important subdirectories. Another important subdirectory is cache. Okay, so this one, so it stores cache data from application. Example are package manager, apt archive. So when you install software, the Debian installer file are kept here, so you don't have to download it again if you reinstall, right? Another one is man, so it is pre-formatted manual page for quick reading, font config, pre-calculated list for available fonts. So cache is temporary, it is safe to delete it as the system can always recreate or re-download it, though the system might run slower if you download it again and it tries to relearn from the data, so it takes a while for the cache, right? So another subdirectory is spool. So spool stands for simulation peripheral operation online. It is holding area of tasks that are waiting to be processed by a program or a piece of hardware. So basically to memorize or to visualize, think of a printer. If you need a 50-page document to print, your computer doesn't sit there frozen, right? So instead of what it does, it spools data into var/spool. The data sits there comfortably while the printer slowly works through pages one by one. Once the job is finished, the data is gone. Okay, so let's see /var/spool, right? So you'll see bunch of files. We will be discussing about a mail over here. So var/spool/mail, this is where incoming mail sits for user until they open the mail to read them. Another one is cron that we discussed earlier. It is used for scheduling, right? So when you edit by running cron tab /e, the editing is being stored over here. Another one is so most important, I would say, is rsyslog. So it is so meaning of this, or full form is reliable system log, is the service responsible for collecting all the messages from kernel and application and writing them to var log. So rlog writes a message directly to the disk. However, rsyslog is often used to send log to another computer over a network, which we can say is a central log server. So if your internet goes down or the central log crashes, right? So it crashes. So r/ doesn't want to lose that important log message, so it spools them to var spool rsyslog. The log sits the spool as in the spool as a temporary file, and r/log keeps checking the connection. As soon as the connection is back, right, it processes the spool, sending all the backed log to the destination. So your rsyslog may be empty as it is normal user. So here we can check our rsyslog. So what we can do is you can check by doing var spool. So I'm sorry, I think permission will be denied. I might be wrong though. Yeah, permission is denied. So what we can do is, for this you can do sudo ls. So if you do this, I think I entered my password wrong. Yep. Let's do this again. Okay, so it should be running. Okay, since if no file means your system is healthy. Your log is being written to the var/log without any traffic jam that we discussed earlier. Okay, so another we are gonna learn another subdirectories that we are gonna learn is var crash. So this we are gonna learn. So when a program doesn't just quit, right, but crashes, like a segmentation fault or something, the system tries to capture a snapshot of exactly what's happening in the computer memory at the exact microsecond. So what's inside is there is a core dump or a crash report. On a system like Ubuntu, you will see files. If it is crashed, then you will see with starting from .crash, so something like that, like here. So why is it there? Like a developer or us, or like a system admin, can figure out what the problem is. Here, just look at so here I ran a simple command, right? So what's inside my this? If you are not receiving any file, then simply use -h. It shows in readable format. If no any file is being shown, then it's perfectly healthy. Your system is working, your application is behaving perfectly. But here a few days ago my Genome crashed on my system, and I had to reinstall it, and it's showing that one. So basically a live example is here, a practical example. When my Genome crashed, right, my Genome is stopped working, it crashed, right. So it is being stored in our crash file. So it's basically that. Another subdirectory that we're going to discuss is, which is matrix. So what we're going to do is we're going to learn about matrix. So matrix, here we can say, is a directory. It is recently newer folder in Linux world. It is where the system stores data about how it's performing, what's inside. So what's inside is basically small data file tracking things, like how long it takes to boot it. Basically it takes to boot, how much data was sent over the network, or how much battery was used. So for this, let's use a font command. What we're going to do is what we did for this. If you see 0, then that means your system is perfectly fine. So this is what you're going to do. Another subdirectory is what we're going to learn is temp. So you might get confused from crash, spool, and temp. Please don't get confused about this. So what basically is so here file is saved even after reboot. Okay, largest file that needs to survive reboot or restart, so it lives basically in hard disks. So if hard disks, so if you are downloading 50 gigas file, and an installer needs to put the PC somewhere, right, it's a big file. So while it works, so it uses var/temp. If the power goes out, right, data is still there, you can turn the computer back on, and you can reinstall it. So it's basically a big chunk of data is gonna be stored here. So you might get confused from our cache and spool. So cache is basically a data is kept so it can be reused later, right? But spool is data is kept because it is waiting to be finished. Once processed, data is gone. Okay, so it's that. So another directory that we are going to discuss is our temp directory, which is temp directory. So it stores temporary file. It stores file which are needed only for a short time while the system or application are running. So /temp is usually cleared automatically on a reboot. Okay, it doesn't stay like in our cache. So that's the key difference from our var/ and temp. Our var temp, right? So temp, it is cleared on reboot, where var/temp it is not cleared on our reboot. So temp is basically known as temporary file. Okay, it stands for that. So what lives inside our temp file? So if you run so what we're going to do is, if you run ls, basically what we're going to do is la, we're going to use combination of our flag, which is /temp. What we're going to see, you'll see bunch of files. You'll see bunch of strange looking files. These are usually temporary socket or a file or a log file. So let's see the permission of temp. So basically what we're going to do is we're going to see our this for we're going to use a combination of flag. So we're going to use d. So what d does is, so it says to the directory that show the property of directory. So here drwr wt. So rwx is basically it means anyone can read write. This t at the end, it is known as a sticky bit. So what this is, it plays in a vital for security, right? So /temp is basically a world writable folder. Any user or program can put a file there without sticky bit, right? Or another user can delete another user temporary file. So this T ensures that only the person who created a file can delete it. So basically is basically that. So never save your file at /temp, because it might get blown away when your system is restart. Okay, so let's do a fun command again. What we're gonna do is we're gonna use a dix-free command with our human readable flag. We're gonna see temp. So let's see. So here, if you see your tmpfs under the file system in your RAM, it's very good, it's very fast. But here, as you can see in my system, it's using dev/sdav2. so this means it's running on our DIX. So it's basically my temp file is running on my DIX, which is a bit slow compared to RAM. Okay, I mean it's very slow compared to RAM. So let's move to our another directory, which is our boot /boot. Okay, here it is, our /boot. So /boot contains file required to start boot the Linux system without so /boot, right? So without /boot, Linux cannot boot or start. So what happens during boot is system powers on, right? And firmware BIOS runs, bootloader starts from /boot, Linux kernel starts, system loads, and login appear. So during these steps, our /boot is involved in our step 3 and 4, which is bootloader starts from the /boot and Linux kernel starts. So basically there. So files inside /boot are, so let's run our /boot. So you'll see bunch of files, right? You'll see files like this one is very important, vrn linux. So this is the complex Linux kernel, main core of the operating system. This is your main this is the compressed Linux kernel. Okay, another one is initrd image. So this is a temporary root file system. It helps kernel load driver and mount real root. Okay, so another is boot folder, which is the most important, I would say, grub. So this is a configuration for boot menu. Okay, kernel selection. So this is the most common bootloader. So in Linux, grub is the most common, I think, bootloader. For older Linux operating system, LO used to be used, but for now grub is the most kernel system. So let's use another fun command, which is type uname /r. This is basically saying, so see, this is your kernel. So this is your running kernel, right? So this and our VM Linux 6.17.0.14 generic. So this is basically a kernel. So this is kernel version that is running on a machine. So these are the directories that we discussed, which are the fundamentals in our Linux file system. In our next video, we will be covering other directories, which will be /dev, /prc, /system, and /mnt. So we will be covering this in our next video. Please practice the command that we discussed. If you have any question, please feel free to ask in comment section. If you want this handwritten handwritten notes, please, it is in my GitHub. The link is given in the description. So happy learning. Thank you all for watching this video. Thank you.